So, hi everyone. Today I would like to discuss a very important topic, which is AGI, Artificial General Intelligence. This is probably one of the most overhyped topics in AI. But today I want to take a practical approach to AGI. I want to explain what is AGI. Are we anywhere close to AGI? If not, when will we reach AGI? Are large language models AGI, or are LLMs step towards AGI? So I'll discuss all these topics one by one. And just a reminder, you can download the slides from my website. The details are given in the description. You can download the PPT format and you can use them for your own purpose. So I recently noticed that almost 93% of the viewers of my channel have not yet subscribed. So this is just a reminder to please subscribe my channel. So I have taken the information for this presentation from various sources, and this paper, Levels of AGI, Operationalizing Progress on the Path to AGI, has been very helpful. I have also consulted some other papers, and I also added opinions from some academic and industry experts who are very vocal on this topic. In AI, human brain or human intelligence has always been the North Star that we want to mimic. AGI, or Artificial General Intelligence, is an AI that will perform superhuman on a variety of tasks. It should not be one task, it should not be one particular class of tasks. Rather, it has to be a variety of tasks in multiple domains in order for it to qualify as an AGI system. There are many questions that arise. Should that architecture mimic human brain exactly? Do we want to create another human like creature, or do we want to create another human brain like system? So the answer to this, in my opinion, is that no, we just need to get inspired by human brain. We are not creating another human, we are not creating a Hollywood robot here. Okay, so for example, neural networks are loosely inspired by human brain. What that means is that we have human brain, we understand how neuron works to some extent, and we created neural networks that are huge networks of connected neurons, and they mimic human brain. You can understand it by this analogy of aeroplanes mimicking birds. Of course, like, they both follow same phenomena for providing the lift, but aeroplanes don't work like birds. We know that for a fact. Okay, so in the same way, we want to mimic to an extent it makes sense, but not beyond that. So we are not creating another human, we are not creating a Hollywood robot. So because we are talking about human intelligence and human brain, I just want to briefly explain how human brain works. So human brain is a network of a lot of neurons connected with a lot of synapses. Okay, so a neuron is this kind of structure. The inputs are dendrites, the output is an axon, and it is connected with the next neuron through synapses. Synapses or synapse is where our memories are stored. Okay, the stronger the synapse, the stronger the connection between two neurons. The learning is also very different from neural networks. So usually there is a rule called neurons that fire together wire together. Okay, so the neurons that work together a lot, ultimately they develop a very strong connection. You can see it in tasks that we learn, for example, driving. We put a lot of effort initially, but then it becomes part of our habit because they develop very strong connections here. There are some properties of human brain. For example, associative memory, sequential memory. Associative memory means once we remember our university days, We remember a lot of stuff connected to university days. We start remembering our friends and so on. Okay, so sequential memory, for example, you can say A, B, C, D in this order, but the opposite order seems very difficult for us. Both are say everything is saved in the brain, right? But why it's so difficult? So, and then system 2 become like the task that we put a lot of effort into become part of our habit as we practice more. And LLM shows, large language model shows this kind of behavior in their architecture also. So let's look at the evolution of AI starting from deep learning. So we started with narrow AI where we required a large amount of labeled data, and the model was able to learn a single task with superhuman accuracy. For example, image recognition. Now we are at, with large language models and foundation models, we are at broad AI. So broad AI, now we can learn multiple tasks in a single model that are multimodal also. Multimodal, it means, for example, natural language plus um, images, for example. These models can do some kind of reasoning, and they also provide some explainability. General AI, which will appear sometime in the future, will be revolutionary, and it will be able to perform cross domain learning and reasoning. It will have some autonomy, it will understand human morality, it will understand how humans reason. And for example, like current models still need humans to guide them. For example, prompt engineering. Okay, all that will disappear with the general AI models. That can happen in coming few decades. How to evaluate an AGI system? The most well known test for operationalizing AGI system is Turing test. The Turing test is kind of an imitation game where a human, in this case C, talks with two different systems, A and B, and through some message exchange. And it does not know if A or B is a human or an AI system. And if C cannot recognize between the human and computer system or AI system, then the AI system, or A in this case, is said to be an AGI. Okay. Now we understand that this test does not do justice to the network. For example, it does not measure how much data was used by the system A. It does not measure how much power it is using, for example. Okay, so it is insufficient to analyze AGI as we know, as we now understand, and the LLMs can pass in some conditions. They can pass Turing test already. Okay, but some people are also of the opinion that they are good at fooling us into thinking that they are AGIs while they're really not. Okay, so as I said, so in some framing of these tests, they can perform very well. But one thing that we do agree with Turing test is that we want to focus on capabilities rather than process. So, for example, a person who is sleeping or just resting, he might be the most intelligent person in the whole world, but we don't have any way of analyzing that unless he start acting on the world. Okay, so that is what we want from these models also. We cannot say these models are intelligent or these AI systems are intelligent unless we see their action. So we are more interested in the capabilities, not the process by which they do something. Okay, so what's the difference between retrieval with interpolation versus intelligence? Let me explain that a bit. So, if we have a system that has access to all the knowledge, all the written text, images, speech, videos there are in this world that were ever created, and it is extremely efficient in retrieving that information, and it can interpolate to some extent, not extrapolate, not go beyond the boundaries, but it can interpolate. Can we say that that system is intelligent? Um, will it know every situation that it will face in the future? So, this topic has been widely discussed, and we know that we cannot have enough knowledge or enough data um, that can make a system intelligent just by retrieval and interpolation. Okay, so we should understand that the whatever deep learning, whatever large language models, foundation models we have are extremely amazing retrieval with interpolation systems. Okay, so there is something missing. There is something missing. They are getting better day by day, um, but we cannot say they're intelligent in AGI kind of meaning. So here I have listed levels of AGI and reality check where we stand right now. So the first column shows different levels. Second column shows the application of that level in narrow settings, and the last column shows in general setting. Okay. So level 0 is no AI like calculator, compiler, or human in the loop. Level 1 is emerging, and this is um, it will perform equal to or somewhat better than unskilled human. Okay. This is where large language models are right now. Under general settings, they perform better than unskilled human in a lot of different domains. Okay. Level 2 will be competent at least 50th percentile of skilled adults. Under narrow settings, we can understand, for example, IBM Watson, Alexa, Google Assistant. They perform under narrow settings better than. Okay, my Alexa responded to me. Uh, so this is where AI systems are. Anyways, so but under general setting we don't have anything right now. Okay. um, Level 3 will be expert, where we achieve 90th percentile of skilled labor. And here again in narrow settings we have, for example, spelling, grammar checker, image generators. Level 4, 99th percentile of skilled labor, skilled adults. Okay. This is where, for example, IBM's Deep Blue, the chess player was, and AlphaGo, the Go player, okay, was in that particular domain. It's very very good, but in general settings, no, it cannot do. And level 5 will be the ultimate AGI, which will outperform 100% of humans, even expert humans, okay, in that domain. It will work across different domains, and this is yet to be achieved. Okay, so we understand like where we are in general settings. We are at level 1 right now. So I took the slide from Gary Marcus's talk at Nuclear Workshop AAAI 2024. The title was No AGI Without Neurosymbolic AI. And he gave 7 different points, and he believes that we have already achieved one, and to some extent number 2 also, but the remaining are still missing. Number 2, that he thinks to some extent we have achieved is extensive real world knowledge. Okay. We understand that LLM's foundation models are extremely good at encoding a large amount of world knowledge. Okay, but what is missing, we can also see from these. For example, compositionality is missing, reasoning in the true sense is still missing, and few other things also like common sense knowledge are still missing from these large language models. It is very difficult to formally define AGI because people have different understanding and expectation from an AGI system. But there are 6 principles that more or less everyone will agree to. Um, the first one is that we want to focus on capabilities, not process. We don't care how it is doing that as long as it is doing what we want. Okay. Number 2 is focus on generality and performance. Like we are interested in performance, but we want it to be general across many different tasks or domains. Then focus on cognitive and metacognitive tasks. We cannot say that this system is not AGI because it doesn't have a body. It cannot do physical tasks. So that's not what we want. Okay. Then focus on potential, not deployment. For example, the system can be very expensive to deploy it or maintain, but again, we don't care about that right now. Focus on ecological validity. So some of the tasks, for example, can be hacked into showing like good performance through some shortcuts. Again, that's not what we want to do. And focus on path to AGI, not a single endpoint. So in the end, we don't expect AGI to be a single system that will take over the whole world. So that's not what we are looking for. And large language models have already shown us like it's not one size fit everything or all. Okay, let me talk about the risks of AGI. So we fear AGI a lot because of how it is shown in the movies and novels. Um, but I believe strongly that there is no reason to think that AGI will destroy human race. Humans will still be in control. Um, However, that being said, AGI is already and will affect us in many ways. AI, for example, is already affecting us in many ways, and AGI will be no different. Here are different levels. For example, at autonomy level 0, like calculator kind of things, we understand there are almost no risks there. At level 1, where we use AI as a tool, we just ask AI to do repetitive tasks like grammar checking and stuff. Still, we understand the risks there. At autonomy level 2, the actual risk starts. Okay, here we use AI as a consultant. So for example, we ask AI to summarize documents, create recommender systems, generate code. Here we have like overtrust, radicalization, targeted manipulation as potential risk, and we understand how this is already happening with today's AI. Autonomy level 3, where we use AI as a collaborator. Okay, still human is in control here. Human is leading the AI into doing something. But we'll see a rapid societal changes at this level. Autonomy level 4 is where the AI derives the interaction. Okay, this is the level where we will see a mass labor displacement. There are many jobs that can be in danger at this level of autonomy. And level 5 is fully autonomous AI. And this right now, we don't understand this level very well. But with the proper governance of AI, I strongly believe there is no reason for us to fear autonomy level 5 also. Another question that I wanted to answer is some people do believe that give us all the compute in the whole universe and give us all the data in the whole universe, and they claim that they can give us AGI. However, this is not true because of many different reasons. Okay, first of all, the reason is qualitative limitations. More data does not mean that the quality of data is also increasing. Okay, um, there is a limit to how much good quality data will you have and how much unique data will you have. Understanding and reasoning, I told you, so and a system that have all the knowledge in the whole universe with excellent retrieval does not give you reasoning capabilities of human. Okay, so for example, it will lack basic human intuition no matter how much data you show it. Learning efficiency, so it's not about like our AGI systems should not learn from everything there is in the world. Okay, they should be very efficient machines that can learn with a very limited amount of data, just like humans do. and generalize it so well and apply compositionality so well that it does not need so much data. Okay. Then ethical issues. Um, like more data will increase bias probably. Okay. It will definitely introduce lack of transparency and other issues. Okay, we'll not understand exactly what the model has learned, and there is a need for innovation here also. So we cannot think very narrowly that LLMs are the solution to whatever will happen in the future, and the only way to go forward is keep feeding these LLMs. They're extremely important part of the puzzle. They have solved a lot of things, but we do need still to um, find some novel approaches um, that solve the shortcomings of LLMs. So, if you look at the industry, academic experts, they are of very different opinion when it comes to AGI. For example, here, there I have copied a conversation where Elon Musk said that by next year we'll have AGI, and Gary Marcus is of the opinion that this comment will not age well. Grady Bush have similar comment that AGI will not happen in your lifetime or your children or children of children lifetime. Um, on the right hand side, you can see that a statement that was signed by different industry leaders. Mitigating the risk of extinction from AI should be global priority alongside other risks like pandemic wars. Stephen Hawking was of the thinking that full AGI can spell end to human race. Okay, and you can see another interview where Hinton was asked how could AI kill humans. And this, I have taken these quotes. You can find many more interesting quotes and material on stop.ai. I strongly believe we should not stop AI by any means, but just like we govern other things, I think there should be some governance around how AI systems work that are deployed in real world applications. So these are some things we should already start preparing for. Economic impact. We know that the efficiency will increase in a lot of industries, but that also means potential job displacement. Ethical, social challenges. Um, we don't know how these systems will follow human ethics, human morals, and they can also differ slightly between different countries, between different demographics. Um, and scientific technological advances, of course, like they will accelerate the development across a lot of fields. Regulatory and government issues. I think the regulatory organization will have to create new rules on how to interact with AGI, how to build AGI system, and to reduce the potential risks from these systems. Okay, time for fun fact. While making this presentation, I was thinking what would be my test for AGI. We understand that Turing test is very limited in scope, so LLMs can fool us into thinking that they are already AGI. But we understand how they cannot do well without prompt engineering, and they can only do some tasks, and they are not very good at reasoning, and so on and so forth. So what would be my test for AGI? Uh, so I believe a system, I would call a system AGI when I place it in a totally new environment and I just give it a high level command and it just do it for do the thing for me. As we saw, like it doesn't have to be an embodied system, okay? But for example, if I have a robot, I should be able to plug an AGI brain into my robot through network or any means, and I should just start asking it to do something for me right away. Make a coffee for me, I should not tell it anything. The map of my house, uh, like how to make coffee, where the things are, what are the safety issues, what kind of stove I have. I should not be telling any of that. It can figure just like an average human can. If LLMs can do this already, then LLMs are AGI. Yay, we have solved AGI. So, but we know LLMs are very far from this right now. Okay, so just fun fact. If you find any problem with my AGI test, do let me know. I'll be interested. Okay, so as you know, there are many ways to connect with me. Subscribe to my YouTube channel, connect with me on X, LinkedIn, and you can download the PowerPoint slides for this talk at this link. So feel free, leave me a comment. Thank you.